All right. Does anyone have any questions about some practical things like textbooks or calculators, anything like that? Is everybody good with getting
Yeah,
those?
what kind of calculator do we need again?
A scientific calculator would be
Okay,
fine.
thank you.
Yeah. Okay. All right. No other questions? Okay. All right. So we're going to cover today the first two chapters of the textbook. Um, and should go pretty quickly, even though there's quite a few slides here. There's some definitions and so forth that I will point out to you as we go along that you would be responsible for knowing. All right, now in these slides, just so that you know, there's what are called thought questions at the very beginning. It seems like every chapter is like this. So these are just questions that are posed ahead of time before you learn anything to see if you have any opinions about these things. So you could just unmute and let me know what you think. Um, so this first one says a recent newspaper article concluded that smoking marijuana is at least three times a week resulted in lower grades in college. How do you think the researchers came to this conclusion, and do you believe it? So anybody have any ideas of why
I would
somebody would
They
I
have
would
probably
think I would think they did a survey maybe.
a survey? Okay,
yeah, and
Quest-
like also
a questionnaire.
right. Questionnaire, survey. So that would be how they probably did it. Okay. You wouldn't think that would be an experiment, right?
Um I mean it could be.
Right.
Um they could have.
yeah, that's what I was thinking, like an experiment.
Experiment.
Mhm.
Okay.
Like
I think that the question is a little too vague in order for it to be an experiment because you would have to take a lot more things into consideration
Okay.
modeling if it was an experiment.
More things into consideration. In other words, what you're saying is the experimenter would have to control for other things. Is that what you're saying? Something like that?
Yeah.
And I
Right.
think that's why I said a questionnaire or survey.
Right.
'Cause
Right. And
she's right.
also, if you were going to do an experiment, you would, yeah, some people to smoke marijuana and some people don't smoke marijuana, and it may be illegal in the state that you're in, right? So it's not something that I would think an experiment would actually happen because of the what you're actually experimenting on. So yeah, I think you're all gave good points, and also says, do you believe it? Smoking marijuana is at least three times a week, result in lower grades. Is that believable, do you think?
Um
yeah, I think it's
it
believable.
could be it's possible.
Yeah, yeah, sure.
Because I'm a recovering addict, so I know like when back in my early years when I smoked marijuana, I didn't even in the school high all the time and didn't want to do my work. So yeah,
Okay.
and I'm speaking from experience. All I did was laugh at the teacher.
Yeah,
I
well,
was
I'm glad I wasn't the teacher back then. I'm a teacher now, so thank you very much. Uh, um, but yeah, I appreciate your comments. That's great. Great comments. All right. Let's see. Sometimes it's stuck here. Let's see. 1 second. There we go. All right. Here's another thought question. On average, men have lower resting pulse rates than women do. And the question is, that's a theory, all right? Who knows if that's really true, but how could you go about trying to prove or disprove that? Would it be sufficient to measure the pulse rates of one member of each sex or two members? How do you
would
feel about that?
have to do a significant amount of each sex in order to determine that. So you would definitely need, I think it's called like I think it's like a sample size, something like that. You gotta do like a sample.
I would think an experiment.
Correct. So an experiment would make sense, right? Because you want to see if there's a cause. The cause actually being gender in this case, right? You want to see if gender has an effect, and you would have to control for other possible effects. So yes, I would agree with that. And also the idea that you would need significantly more than two people, right? In each
Yes.
group. I would agree with that too. So very good. Another one here. Suppose you were to learn that a large state university in a particular state graduated more students who eventually went on to become millionaires than any of the small liberal arts colleges in the state. Would that be a fair comparison? How should the numbers be presented in order to make it a fair comparison? Anybody have any ideas about that?
The type of jobs that they got.
Okay, sure. Type of jobs.
The type of school.
All right, I didn't hear that. What was that?
The type of school,
The type of.
like the type of college.
Mm-hmm. Okay, good. So you're saying that it may not be a fair comparison because of those issues, right? Is that what you're saying? What about something that's being highlighted in both those phrases there? What else would be a reason why, if we were looking at the number of students as opposed to something else, what's unfair about the number of students when you're looking at the two groups here?
The large one would have more.
That's right. Absolutely. So how would you compensate for that? What would you what type of number would you compare the two? Instead of absolute numbers of millionaires, what would you do?
Numbers that the small college has. So
Like the
it's like
percentages.
balance it.
Yeah, good. And I did hear somebody say percentages.
Yeah, like the percentage. So like, what's a percentage like of people that went to college in a large university, like out of 100? And same thing for the small liberal arts college. That way it kind of is more even, and like you just see how much of a percentage each school became millionaires.
Excellent. So that would make sense, wouldn't it? That if we have a large population, a small population, then absolute numbers, counts, wouldn't be a fair comparison. But if we did a percentage, or as you suggested, Colby, right, Colby? As you suggested, the number of people per 100 or 1,000 or something like that, that would be a fair comparison. Good. All great points. Thank you. And here's another thought question. I think we're running out of thought questions. Yep. Okay. And it's March. Now, these slides are obviously old because we're dealing with 1995. I mean, that's old, right? 26 years ago. And it's March the 3rd to 5th, 1995 issue, USA Weekend magazine asked readers to return a survey with a variety of questions about sex and violence on television. Of 65,142 readers who responded, 97% were very or somewhat concerned about violence on TV. Based on the survey, can you conclude that about 97% of US citizens are concerned about violence on TV? Why or why not? So what is your opinion about that?
No, because it's saying 97%, like I guess 97% of people that watch TV, but not everyone watches TV.
Okay, okay, good. Well, let's assume that the population that we're choosing from are people who watch TV. All right, let's just assume that's the population. What else could you say about the survey that might make you a little skeptical about this?
It says conclude that about 97% of U.S. citizens. Some people that replied to the survey could be that they weren't U.S. citizens.
Beautiful, beautiful. So what you're basically saying is, does the readership of this magazine represent the population? And you're suggesting it may not, right? It may not. And it could be, there could be some biases in the group of people who
Yeah.
read USA Weekend magazine, as opposed to the general population. Maybe you're leaving out certain groups of people that wouldn't read that, right? They wouldn't read that at all. So yes, this could be a biased sample. And that's something we're going to talk about later. So great. So basically, what this statistic is showing here only applies to people who read USA Weekend magazine, and not really to anyone else, if the readership is not representative of the entire population. So great, that was a great response. All right, so now let's get into some definitions. And first one is about statistics itself. And it's a collection of procedures and principles for gaining and analyzing knowledge, right? And it's collected usually as a data set. And in order to help people make decisions when faced with uncertainty. So there's this idea of uncertainty, right? Because many times we don't have access to all the data for an entire population. Now, there are some exceptions. Of course, the US government in 2020 did a census where they tried to, in principle, tried to contact every household in the United States and ask them to answer some questions. All right, let's pull a census.
Calm down, I'm in class. I'll let you know when I'm ready.
All right, if can people put themselves on, that's great, thank you. All right, anyway, in normal circumstances, however, we don't have access to all the data from the entire population. So we do have to come up with a sample or a subset of that population. And therefore, there's going to be some uncertainty that whether the results from the sample truly represent the population. So that uncertainty is something that has to be dealt with, and statistics has procedures for that. Now, in this course, as opposed to Statistics 1, the more procedural type course, where you learn more statistical procedures, this course is more about interpretation. Now, you'll learn a little bit about some of these procedures, but basically more about interpretation. So this course is for people who need a statistics or math course, but don't need to know all these procedures. All right, so that's something I wanted to throw in there also. All right, what types of questions do statistics answer? Well, they give some examples here. For example, which route should you take to go to school or class or work? How would you determine that? Well, you may sample a few times for each of these routes and see which one was best for you. All right, the sampling is used, and then you do some sort of comparison, right? So in our course, we're going to be using numerical comparisons as opposed to just some sort of judgment. But regardless, that's basically statistics is used to basically see what is the best alternative. All right, so this happens in business and education, all sorts of things in life. Here's an example of, and also statistics is used for research questions, all right? So if you're a researcher in a particular field, you may be interested in learning something about a particular question. So here's one here that has to do with emotions and the heart. Talks about, first of all, the hypothalamus, which is, of course, in our brain. The hypothalamus is a structure in our brain that deals with emotions. However, most people make the connection between the heart and emotions, right? That's typically what people typically do. So there was a psychologist named Lee Salk. He had a very famous brother who developed the very first vaccine back in the 1950s. for polio and so forth. But so Lee was his brother, and Lee was a psychologist, so he was interested in to see if the heart had anything to do with emotions. So what did he do? He observed rhesus monkeys at a zoo, and he noticed that rhesus monkeys, the moms, tended to hold babies on their left side of their bodies near their heart on 40 out of 42 occasions. Okay, so that was an interesting observation. Out of 287 human mothers within 4 days of giving birth, 237 or 83% held their babies on the left, regardless of whether they were left-handed or right-handed. Another interesting observation. Here's another observation. Out of 438 shoppers leaving the store with one bag, exactly half carried the bag on the left. All right, so it's just a bag of groceries, right? And normally you don't have any emotional, unless you're really hungry, you don't have any emotional connection to your bag of groceries. So here it's like a 50-50 thing going on. A dental patients asked to hold a 5-inch ball while teeth were worked on. Substantially more than half held it on the left under stress. So it seems though, that, according to Salk, that there must be some survival value to have your newborn placed close to the sound of a mother's heartbeat, or, and it seems to actually go into other things that have emotional content to it, where like with this 5-inch ball, when you're under emotional stress, you tend to hold it closer to your heart than otherwise. So it's an interesting conjecture. So what did Salk do? He created an experiment, all right, and went to a New York City hospital and to a nursery there. And there was 2 groups of newborns that he did an experiment on, with obviously the parents' approval. And so these were randomly assigned to these 2 types of so-called treatments. One treatment was continuous sound of human heartbeat over a loudspeaker. And the second group didn't hear that. They didn't hear any sound at all, just normal sounds around them. And they wanted to see if there was a weight gain or loss after 4 days, if there was any significant connection there. And he found that infants treated to the heartbeat sound gained more weight or lost less weight and cried less than the babies who didn't hear the human heartbeat. So, and again, a very interesting connection there between the heart and emotional comfort. Okay, so basically this is an example of the type of question that's you can do a study on, right? Somebody has some observations. They think, all right, let's do an experiment to see if there is a connection. All right. So what are other things that statistics does? Well, sometimes it tries to detect relationships and patterns. What are the types of questions that you can ask? Well, are men on average taller than women? Does aspirin help prevent heart attacks? In certain months of the year, this is something that a clothing store or a retail store would be interested in. In certain months of the year, are people more likely to buy blue jeans? If it's true, then those months of the year, maybe the store would put more sales out for blue jeans. Men have lower resting pulse rates than women. I don't know about that, but could be somebody's idea. Does listening to Mozart, his music, does it improve spatial reasoning? These are the types of questions you can ask and use statistics to help you answer them. All right, so the question is, how do you create or design a statistical study if you wanted to answer any of these questions? Well, number one thing that you can do is you need to get yourself a representative sample. Now, how do you do that? Well, we'll talk about that later. Representative of what? Representative of the population that you're sampling from. You need to have a large enough sample so that the variability within the sample we can say something about the variability within the population. And then an important choice also is whether our study should be observational versus a randomized experiment. We'll talk about that also, we'll define those terms in a minute. All right, so again, here's another example. We want to assess if men have lower resting heart rates than women. So what do? We get a sample from the population. And the sample, of course, are the people who actually are studied in the study. Population is that larger group from which the sample was chosen. By the way, the population, when we talk about population, it doesn't mean everyone in the United States, everyone in the world. It means the population that we're interested in, right? It could be students at Rowan University. That could be our population. It could be.
Would the sample be, if the students at Rowan University is a population, would the sample be like males or females? Like, could that be a sample?
Sure, but you have to be careful because you have to make sure that I mean, if you're sampling just females, for example, maybe your population is all female students at Rowan University. Remember, the sample is nothing more than a subset of the population. So it should represent the population. So it's a good question you're asking. If the population is all Rowan students, could the sample be just female Rowan students? The answer is no. It should be similar to the population. So it should be like the population, just a smaller version of it, a mini version of the population. All right, and the reason for that is that you want to extend the results from the sample to the population. So if the sample really is not like the population, then it's going to be difficult to extend or generalize the results to the population that you're interested in.
So can you give an example then of exactly what you're talking about, since you said that the population, if it's Rowan University, it wouldn't be females or males? Like, is it something specific? Like, so if I say the population is females at Rowan University, and then the sample would be females that live on campus at Rowan University, could that be a sample, or is that still too broad?
Yeah. I think what you have to understand, so what you're doing is creating another population. You're creating another subpopulation within the larger population when you're trying to. The sample should be the same type of students as the population. So if you're saying females, I'm interested in looking at female students at Rowan. Well, when you take a sample of, and the only reason you're taking the sample is because you may not be able to talk to or deal with everyone all females at Rowan. So you decide to sample, but it should be the same group of people. So if your population, if your research question is interested, it has to do with female students at Rowan, and you want to know something about them, all right, for whatever research that you're doing, and you know that you can't ask every female student in Rowan, then what you need to do is do some sort of sampling procedure and sample the same type of student. You're going to be, in other words, drawing people out of a population. For example, let me give you an example. Suppose there are 5,000 female Rowan students, all right? And then you number them 1 to 5,000. Each person has a number associated with them. Picture putting all those pieces of paper with numbers on them into some sort of big basket or something, and you mix them up, and then you put your hand in there. And let's suppose you want to survey 100 of them. What are you going to do? You just put your hand in and pick out a piece of paper with a number on it. And you do that how many times? You do it 100 times. And those students out of that population that have been selected are going to be the ones that are going to be sampled. So it has to be the same group. So
Okay.
don't change the group. If you change the group, then you have a different population. See what I'm saying? So it's just a subset. You're just pulling out a small number of all those potential people in the population. And that's how you do it. That's called random selection. Randomly selecting people out of the population. Okay, does that, I don't know who asked that question. It's a good question, but we don't want to redefine our sample in terms of the type of female Rowan student, because then we're creating a new population. So we have a population that we've selected because we want to study that population, and then we randomly pull out people from that population, and they could be people who live on campus, they could be people who don't live on campus. We don't know that when we randomly pull them out. And then at that point, we could, of course, classify them one by one. We could ask them questions about where they live, what courses they're taking, whatever we want to ask them. But it's still the same population that we're drawing from. Okay, I hope I answered your question. So you have to be very careful when you define your sample. You don't want to define it differently than the population, because then it itself becomes a population. All right, I guess it was clear. Now, in this case for pulse rates, we could have what's called a convenience. They say convenience sample. I think I've seen it written as convenience sample. What is a convenience sample? Well, suppose you put an ad into some sort of a post in Facebook or something. I don't know. You post something that requests female Rowan students to be part of your sample, and the first 100 people that respond to the posting get selected for the sample. Well, that's called a convenience sample. Convenient meaning it was easy to select them, right? It's just the first 100 people who responded to your advertisement. It may not be very, very representative of the population. So in that case, you can't, even though you can gather statistics for the sample, for whatever you're measuring, you cannot extend it to all female students at Rowan, because it could be that the students who did not respond think differently than the ones who did respond. So it's not necessarily a good way of selecting your sample. It's not random, it's called non-random sample. Okay, so here it says you cannot extend it to other age groups or whatever the criteria is in this particular case on the slide. Okay, so it looks like I'm stuck again. Oh, let's go back. Okay. All right, number 2, how large of a sample? Well, if you were taking a regular statistics course, there would be a formula for determining this. All right, and this is something that we talk about in later on in this semester. I'm also teaching statistics 1, and so this is a topic I will be covering with those students. But since we're not really doing that sort of calculation in this course, the question is, how large is large enough? Well, in this case, we're not going to come up with a number of people, a minimum number of people in your sample. But one thing that we could say is that based on the responses for a variable, for a research question, depending on how varied those responses are, the more varied the responses, the larger the sample that we need to detect if there's any significant difference between different groups. Okay, so the more variability in the responses, which means the more variable the different responses are, the larger the sample that we need to detect the differences that we're looking for. So that's something that is important. Sometimes I do ask a multiple choice question about this, so you may want to make note of this particular relationship. The more variable the responses of a variable are, the larger the sample is needed to do the research.
Can you repeat that one more time?
Yeah, so suppose we collect data to make it easier, let's say we're just looking at the height of female students at Rowan University, all right? So we draw a sample from the population of female students at Rowan, and we just measure their heights. Suppose the heights are very variable. There's some students at Rowan, with lady students at Rowan, who are like heights of a gymnast. You know, lady gymnasts can be less than 5 feet, right? Many of them are. They're like 4'8", 4'9", 4'10". And then there's all the others who are in the sample who play basketball for Rowan and who are over 6 feet tall. So my point is there's a lot of variability in the answers to the height question. You know, how there's a great deal of differences between those numbers. And therefore, the larger those differences are, the bigger the sample that we need to detect any differences. Because what happens is, if we were going to take the average of a group of students, their heights, for example, if there's more variability, that average doesn't really represent everyone very well, as opposed to a sample where the heights were very similar to each other. Then the average represents the heights better. So the point is to overcome this idea that variability kind of makes the average sort of weaker. We just need more people in the survey, in the sample, to overcome that variability. All right, so that's the whole idea. The more variable the answers are, the larger the sample that we need to detect any real difference between the answers. All right. We don't need to know the mathematics behind it. This is something is very easy to see if we were looking at formulas. I could show you exactly how that works, but in this case, we're not using formulas in this particular concept, so we're not going to go into that. But this is just one little point here that you should just make note of. All right, the more variability within the data set, the larger the sample is needed so that we can detect real differences between the data points. All right, and this is just an example here. It says for pulse rates, if all men had a pulse rate of 65 and all women had a pulse rate of 75, it's pretty obvious that we would only need 2 people to look at, right? One male and one female, to see a difference between men and women. However, if the men's rate varied from 50 to 80 and the women's rate varied from 52 to 82, then we would need many more measurements to see if there's a real difference between the men's rate and the women's rate. Sort of makes sense? All right, that's exactly the point. And that's all you need to know about this. There's again, no formulas to make this more concrete. Here's an important distinction, definitely something that you need to know. All right, the difference between an observational study and a randomized experiment. An observational study is basically where the researcher is just observing without interfering with the data. Okay, so if you wanted to know if there was a connection between taking aspirin and heart attacks, it's possible you could do an observational study and just ask them, have you ever had a heart attack and do you take aspirin? That's one thing you can do, and that's called observational. You're not really manipulating the variables in any way, you're just asking them about that. The other possibility is do an actual experiment. Would have to be done obviously over time, where maybe you would randomly assign to one group of people aspirin, and then the other group of people will probably get some sort of little pill that looks like aspirin, tastes like aspirin, but it's just maybe sugar, made out of sugar. Doesn't have any active ingredients. And then you study them over time to see if they actually get a heart attack or not. All right, so one group is taking the aspirin, the other group is not taking the aspirin. That would be a randomized experiment. And when you randomize, you are randomly assigning your participants to one of those two treatment groups. Either they take aspirin or they take the fake pill. All right. So in this particular case with pulse rates, it says sufficient to measure or observe both the pulse rate and gender of people in the sample. All right. So, and then it says to learn if aspirin helps prevent heart attacks, an experiment would be better. So here's an important part of this, and it'll be, I'll talk about it over and over again. In an observational study, there could be other variables that could be influencing the results. And since we're not controlling for anything, it's possible that these other variables are producing the results that we're looking at and not the variable that we're looking at. On the other hand, if we do a randomized experiment, we're controlling for these other variables. And therefore, we could actually say that one variable is influencing or causing the results in another variable. All right, like in this case here, aspirin helps prevent heart attacks. It's a cause and effect, right? Aspirin is causing the prevention of heart attacks. You can say that in a randomized experiment because when you randomly assign people to these treatment groups, what you're doing basically is you're creating these two groups that should be, through this randomization process, that should be very similar for all the other variables that exist. And therefore, the only significant difference between the two groups should be whether the person is taking aspirin or not taking aspirin. In an observational study, you cannot necessarily make a cause and effect or find a cause and effect relationship because you're not controlling for those other variables that are out there. Okay. So here's a case here where it says, does aspirin prevent heart attacks? It was a 5-year randomized experiment, really long one, right? And who were the, what was the population? Or who was in the study? Well, in the study was 22,071 male physicians, age 40 to 84. All right, they were in the study. Group 1, again, these were randomized experiment, which means they don't know whether they took aspirin or not. Group 1 took ordinary aspirin tablet every other day. Group 2 took what's called a placebo, which means it looks like an aspirin, but it has no active ingredients, but you didn't know which one that you took. Right? And by the way, if a subject does not know which group that they're in, this is called blinding. All right, so that way they don't influence the results of the study. Now here's a chart, and I think Colby, I think earlier had said something about having a statistic where you would look at the number of people or things per 100 or per 1,000. Well, here's an example of a chart that reads just like that, right? So you have two groups here. You have the aspirin group and the placebo group. Okay. In the aspirin group, 104 of them over 5 years had a heart attack, and 10,933 did not have a heart attack, all right, out of the group of people who took the aspirin. And then out of the placebo group, 189 of them had heart attacks and 10,845 did not. All right, so to find the number of heart attacks per 1,000 people. So how would you find the number of people who took aspirin? You just add these two groups, right? 104 had heart attacks, 10,933 did not. If you add those two numbers together, that was the number of people in the aspirin group. Same thing in the placebo group. If you simply added the number of people who had heart attacks and the number of people who didn't, that will give you the number of people in the placebo group. And you simply count the number of people per 1,000 in your group that had heart attacks. And the aspirin group, it was 9.42 people out of 1,000 had heart attacks. And I'm sorry, oops, went backwards, forwards. And then the placebo group, it was 17.13 heart attacks per 1,000. There seems to be a significant difference between these two numbers, almost double the number of people in the placebo groups had heart attacks. So it certainly looks like, without doing any other fancy statistics, it looks like that aspirin seems to have a good effect on preventing heart attacks, at least from this particular study. All right. And it mentions here, because we did randomization, other factors such as the amount of exercise, I could also say what they eat, are expected to be similar for both groups. So when we're looking at the difference between the two groups, those other factors tend to be excluded. Now, here's the deal. The subjects were male physicians. Now, there were plenty of people in this study, so I think the sample size was large enough, but the population is male physicians. Can you generalize this to all, to women also, to all males, to all women? Anybody? Can you generalize it to all males? Well, the population is male physicians, male doctors. So as much as you want to extend it to all males, well, not all males are doctors. So you can only extend this to male doctors. Certainly you can't extend it to all women, all right, because no women were in this study. So that's the weakness, if you want to call it a weakness of the study, is that it did not generalize to the larger population of males, or even the larger population of all U.S. adults. Well, here's an important part of statistics that people tend to misuse it, right? Misusing statistics, not uncommon. Here's a business magazine that sent 2,000 questionnaires to readers about a Republican primary. And this is a very long time ago. This is back in the 1980s, really long time ago, because you probably don't even recognize who Lee Iacocca is, unless you read some history. He was the president of Chrysler Corporation at the time, and he actually ran for president. This is when they say George Bush, he was vice president when? Under Ronald Reagan in the 1980s, and he became president, the 41st president. This is the dad whose son became president later. This is George H.W. Bush they're talking about. But anyway, there was questionnaires about a Republican primary. This is during their run for president. Based on only the first 200 respondents, Iacocca would beat Bush by 54% to 47%. Well, these are questionnaires that were sent out by a business magazine. So that's number one. That's our population, the business magazine subscribers. And number two, they looked at only the first two respondents. So number one, it's a convenience sample, given that it's the first 200 people, not a randomized selection of people. And number two, the population are readers of this business magazine who probably are more Republican than they are Democrat. So what do you think happened? George Bush won that primary, and he won it handily. All right. So this is the problem with sampling. If you don't sample correctly, you could end up with wrong results. All right. Very wrong results. But in this case, the sample does not represent representative of the population of all likely people to vote. Only those people who subscribe to this business magazine are the ones who gave their opinion. Another example, U.S. EPA study led to a report that New Jersey ranked 22nd in its release of toxic chemicals. Now, New Jersey is a small state, right? Smaller state, less amount of toxic chemicals probably come out because it's small compared to larger states. So what do you do? You change the units of measurement. Instead of saying the total amount of toxic chemicals, you say the total pounds. It says total pounds released. You did pounds released per square mile. It's not a small population. It's a small state geographically. So if you say the amount of toxic chemicals released per square mile, all of a sudden New Jersey is 4th on the list. So before it was 22nd out of 50, now it's 4th out of 50. Which one is more misleading? Well, it would be the one that says it's 22nd, right? Out of 50 states, because they were looking at the total amount released. And if you look at it in terms of square mile, New Jersey was actually did very poorly. There's another one. Study says smoking may lower kids' IQs. All right. What's the implication here? That that smoking causes lower kids' IQs. Now, what do they mean by smoking? Smoking by moms, right? Maybe while they're pregnant. Right? Does that lead to lower IQs when their kids, after they're born, when they grow up? Well, how would they determine this if they did an observational study? Well, if it was an observational study, you can't say smoking caused it, because there could be other reasons for it. Maybe, I'm just throwing this out there. Maybe moms who smoke also, maybe they don't exercise enough. Maybe they don't eat well. Well, we don't know. But the point of the matter is there could be other factors that could be causing the lower IQs, all right, other than smoking. Now, why would an observational study be done here? Because it would be unethical to have an experiment where you randomly assign smoking, pregnant women, one group smokes and another group doesn't. That would be, you can't do that, right? Because it would be harmful for the mom to be smoking. So observational studies have to be used, and we can't actually say smoking may cause lower kids' IQs. Okay. There's other examples here also. Let me see if there's anything else. So I have posted these slides. I think I need to go to the next group of slides. So these are just examples of the same thing. With observational studies, we can't make a causal connection. That's the point. And that's what these others are talking about here. All right. So any questions about chapter 1? So hopefully you got sort of an idea of the types of topics that are covered in statistics. All right, so let's go to, stop sharing this. Let's go to the next one. Looks like I have some chatting going on. All right, somebody asked which book is required for the course. Well, it's I have posted a syllabus in Canvas, and the book is called Seeing Through Statistics. This book right here, Jessica Utts. All right, published by Cengage. You can get that book either from the bookstore, or you can order it on your own. All right, you can even go to the Cengage website and order an e-book copy of it. Although I did hear from quite a few students last semester that they thought after they ordered the e-book that they should have ordered the paper copy. All right, anyway, that's really up to you which way you want to go with that. All right, let's now look at this chapter here, and this one should go pretty fast, actually. So this chapter has to do with how do you evaluate, what steps do you go through when you evaluate a news story that has statistics in it. All right. So let me actually go through these thought questions and get to the real meat of this chapter. There's not a whole lot in here, but there's a couple definitions that you should know about. Number one, what are data? Notice that they use the word are data. Data is actually considered a plural word. So instead of saying what is data, we say what are data. It's a collection of numbers or other pieces of information to which meaning has been attached. Attached to what? To a variable. Now, data does not have to be necessarily numeric. It could be categorical. We can call categorical or non-numeric. But we'll get to that in a minute. So obviously numbers are data when they relate to something that we are measuring. So you could say, oh, how about the numbers 1, 3, and 10? Well, not necessarily data unless the 1, 3, and 10 are something. For example, like the weight gains in infants in Lee Salk's heartbeat study. All right, the amount of grams in weight gains. So then 1, 3, and 10 become data. It's referring, data has some sort of units of measurement, basically. That's what they're saying here. So that's what real data is. I think most of you know that already. Newspapers rarely present actual data. All right, that's kind of true. All right, that's because number one, most people who are in media are not experts in statistics. So it's not like they're purposely trying to mislead, but they're sometimes what they do say is misleading, unintentionally. So the question is, how do we interpret data? Well, it depends on how it's or obtained, number one, and how it's summarized. So that's really important. Here are some of the places that you can get news stories from. Obviously, in today's world, it's going to be more online than it used to be. So used to be you would go to academic conferences, which people still do, obviously, but now they're being done remotely. There's scholarly journals, yes. They used to be more hard copy now they're more electronic. There's government and private agencies that do research reports. There's plenty of that out there. And also different organizations like universities and companies, they have media offices, okay, where they publish information about their institution. Now, in this book, they talk about the 7 components that need to be evaluated when you look at research. And I would have to tell you that in most cases, very few people do this, but this is what's suggested. And it's actually a guideline. Now, the question you may say is, all right, I've read chapter 2. It seems to have these 7 components. Do I need to know what these 7 components are? Well, to be honest with you, your quizzes and your tests are open book. So it's not like you have to memorize these things. You just have to know what they mean. All right. So when you read through this, just try to understand what they're talking about as opposed to trying to memorize it. And then you'll be fine. So what's the first component of doing a critical evaluation of any news story? Number one, what is the source of the research and how is it funded? Okay, well, the funding obviously has something to do with the type of information that's being provided, right? The funding, right? If the funding is from some organization and has a sort of they want to give sort of a certain slant to the way the research is presented, obviously that's important to know that, who's actually funding that research, right? So it's a source of the funding and a source of the research and who is funding it. Could be 2 different entities or could be the same entity. Number 2, who are the researchers who had direct contact with the participants? Do they have any bias in what they were trying to do? Number 3, who were the individuals or objects? It doesn't have to be people, it could be objects, it could be fish, whatever. Who were being studied and how were they selected for the study? That's important to know. Was it randomly selected, and who are these people? Number 4, what type of measurements were made or questions asked? So measurements could just be something, height, weight could be obviously measured, or it could be an actual questionnaire where questions are asked. And this is one thing that it's very interesting. When you look at political polls, and my wife and I had a discussion about this the other day, where we were looking at polling regarding the exact same type of thing. And they were giving completely different answers, different polls that were giving this, examining the same type of question, but giving completely different answers. And she says, how can that be true? How can that happen? And I said to her, it's because maybe the way the questions are asked. Now I studied, besides, I have a master's degree in statistics, but I also got a graduate certificate in survey research from the University of Connecticut, which has a fairly large political science department there. So that's where I got this certificate from. And one of my courses I took there was about how questions are created and how they could influence responses. And it's pretty amazing. Unless you look at how the questions were phrased, unless you actually do that type of research, you will not really understand why different polls or different surveys asking the same type of questions get completely different results. It could be the way the questions are asked. So that's an entire science unto itself. You can have a whole course just on that topic. All right, component 5, the setting in which the measurements were taken. That's important, right? Was it a natural setting? Was it an artificial setting? That sort of thing. See how we're doing with time? Okay, we're good. Component 6 is differences in the groups being compared. All right, what are the differences in the groups that are being compared in addition to the factor of interest? Are there significant differences? Could those differences actually influence the results? That's something that you would need to know. Number 7, sometimes you hear about, something affecting one factor affecting another factor. The question is, how significant is that effect? How big is that effect? That's what the component 7 is asking. Is it a small effect? Is it a big effect? All right, so those are the types of questions that you could ask. Now, are you going to do this every time you hear a piece of research? Probably not. But if you go through this chapter, you would probably see that maybe you'll have a little bit of skepticism when you hear something, right? You're going to start saying, oh, I remember when I took statistical literacy that maybe I should have checked on this, or maybe it's not quite true what I'm hearing. Maybe something else is going on. It'll just produce a little bit of more skepticism instead of just accepting what you hear, right? And that is part of our culture right now, is this thing about, do we accept what we hear, or even if it's the craziest thing that you possibly imagine, or do we have some skepticism, right? And this course is basically saying, forget about the crazy ideas out there. Even though ideas that seem reasonable, we should also question to make sure that the research behind it was done correctly. All right. So these, the rest of these slides here and the rest of the chapter really are just examples of each of these components, just to give you an idea of what you would be looking for if you ever did this type of evaluation. All right. So source number 1, the component number 1 deals with the source of the research and the funding. All right. So here they're talking about 3 main reasons why statistical studies are done. Number 1, it could be a government agency or a private company. They want to make wise policy decisions. All right, so they do a study. Number 2, universities sometimes are paid to do studies. Interesting, right? You see a university doing a study and you think, oh, it must be good, right? Well, it may be that they are not the one funding it. Maybe some other organizations funding it. It would be good to know that, right? Could be a biased result because of that. Number 3, and this is where you have to be skeptical sometimes about companies offering their own statistics. They're trying to convince consumers to buy their products. So do you think they want to advertise what their products think? Right? Oh yes, we have to be, honest about this, and we have to publish no matter what the results are. No, they're not going to do that, right? No company in their right mind is going to do that. They're going to only want to publish things that look good for them. So you have to know that when you look at any information that's coming from a company. Now, it says here it's not always easy to discover who funded research because it may not be something that's publicized very much. So you have to dig a little bit. And you also have to ask this question. The organization that's funding the study, does they have a strong preference for a particular outcome of the study, right? That could, of course, be a biased result. So you have to always ask that question. So component one is actually very important, I would think, is to define who did the study and who, even more important, who funded the study. And do they have any strong preference for a particular outcome? Here's component number two. Who were the researchers who actually had direct contact with the participants in the study? Now, this is important, right? For example, without going through this yet, look at this example at the bottom of the slide here. Now, if you were interested in finding out from people whether they took illegal drugs, would you be sending uniformed police officers door to door to ask that question? And what do you think the answer is? You wouldn't get very honest answers from people who actually took drugs that are illegal because they're standing in front of a law enforcement person. Do you think they would be honest about it? No way, right? No way. So that's obviously a bad thing. Obviously, who actually, if it's a questionnaire, who's doing the questionnaire could have an influence on the responses that you get. All right. So that's another thing about surveys. How are they being conducted? Are they being conducted door to door? Which I think is rare these days, right? You don't get too many people coming to your door asking you surveys. I think telephones, you still get telephone calls. There's some people still do that. Mostly internet now, right? Mostly you see internet surveys. But anyway, knowing who had contact is important because if you know who actually had contact with the participants, you would know what message they were conveying. Maybe they were conveying a message through their body language, not just what they were saying, but their body language. It says participants also give answers or behave in ways that comply with the desires of the researchers. You know, it's very typical that people tend to not want to disappoint who's being asked the question. So even if they feel one way, they'll answer another way so the researchers feel they feel like they've made the researchers feel good. So blinding, this idea of blinding, so the interviewer and the respondent don't know what's really being asked, that's something that would help in this situation. Component number three, individuals or objects studied and how they were selected. All right. How they were selected is very important. You know, I sort of alluded earlier to this idea of random selection, right? You randomly want to select people. You don't want to select just volunteers because volunteers may be biased in the way they are responding, let's say to research questions as opposed to non-volunteers. So you have to know if people were selected randomly as opposed to non-randomly. And you have to know who was actually being studied, right? So this is important for this idea of whether the responses are biased as opposed to unbiased. We want to get as close as possible to unbiased responses as we can. Bias is always in there and we have to sort of minimize it. Only way to know is to actually find out who these people were and how they were selected. How about component 4, the nature of the measurements or questions asked? All right. Now the question is, number one, whatever we were measuring, is it accurate? All right. Were we able, was it something that was being measured that was hard to measure? It's good to know that, right? Because then maybe the measurements aren't as accurate as they should be. Number two, if it was questions, they have to know whether exact definitions were used. Here's an important one here: wording and ordering of the questions. Sometimes if you change the order of the questions, it completely changes the responses completely. And also the wording. The wording could actually influence the responses that you get, also the types of words that you use. Examples: how do you define eat breakfast? What if just juice, or if you eat a snack at 11 a.m.? In other words, you could ask about eating breakfast, but if you don't define it more precisely, some people might think it's breakfast is juice. Some people might think it's some snack. Some people might think it's a large meal. So sometimes the way what phrases or words we use could influence people. All right. So that's important. The setting in which the measurements were taken. All right. Sorry about this, two words on top of each other there. Opinions about locking away criminals would change after a highly publicized murder case. Okay. So sometimes if you hear about something, it could change your opinion about policy. Right? Sometimes telephone calls in early evening would exclude those who work evenings or often eat out. So when you contact participants could have an influence on who you end up getting in your study. Here's an important thing too: when you do research in a lab or university, it may not extend to a natural setting. It's an artificial setting. So that's a drawback of experiments. Sometimes the experiments, you can find cause and effect, but the question is the setting that it's in, does it apply to a more natural setting, a normal setting? It may not. Here's a very important thing: differences in the groups being compared in addition to the factor of interest. If two or more groups are compared on a factor of interest, important to consider other ways the groups may differ that may influence the comparisons. Now, if you do a randomized experiment, theoretically, the groups are going to be similar in other ways because they're being randomly assigned. But you still might want to check to see what the differences are between the actual groups that were selected for factors that you're familiar with. Let's see if they could have influenced the results also. All right, and you can build that into your statistical model if you do recognize these differences. All right, so that's something that researchers sometimes do. Here it says here, researchers may find people who smoke have lower test scores than those who do not. Well, this could be explained by some other factors. They can call them extraneous factors. Extraneous means something outside of the study, right? Such as motivation, right? It could be people who do well on tests, or maybe they're just motivated, right? And those who smoke, this is just theoretical here. Those who smoke also may be less motivated to study than if they didn't smoke. Now, is that true? Who knows? But the point of the matter is there could be other factors that are causing this, the results that you're seeing, other than the one that you're studying. And then component number 7, we only have 2 more minutes, so I'm just going to go through these components, and then the examples in the book, you can read through them. They're just examples of all of this. So you can read through the rest of the chapter and it'll explain these. And of course, these PowerPoints are posted. But let's go through this component 7 and then we'll end our session. The extent or size of any claimed effects or differences. All right. This is very important because there could be a report that there's an effect, but they don't describe how big the effect is and whether it has any practical importance. All right. So an example down here says media reported taking an aspirin every other day reduced the risk of heart attacks. Is it worthwhile to take aspirin? Well, it's better to say that the rate was reduced from 17 heart attacks per thousand without aspirin to about 9.4 heart attacks per thousand with aspirin. So the point of the matter is many times the media does not give the actual numbers, and you actually have to take a look at the numbers to see if it's a material, significant effect. And in this case, it does seem like it's a significant difference between the two. All right, so hopefully this was helpful just to give you an idea of what chapter 2 is about. What's interesting, I would say, and this in conclusion, is that this type of review of how to look at a research claim is something that you don't see typically in other statistics textbooks. You just don't see it. And so this textbook actually does a very good job in chapter 2 in explaining the types of things that you should look at when you hear the results of a research study. And in my Stat 1 course, we don't really go into much of this in the Stat 1 course, and we should, but there's no time because it's all, looking at, calculations and graphing and all. So this is a real strength of this particular course, is that it does allow you to look at how to evaluate research. All right. Any questions about what we covered today? So this was actually a nice, easy introduction to the course. It will get, of course, a little more difficult as we progress, but this was a good start, I hope, and give you an idea of what statistics is used for and how to evaluate them. Any questions? Anything? So next week, I believe, the next one on our schedule, let me just take a quick look. On next Tuesday, we're going to be covering chapter 3, and this is where we're getting to the actual measurements, the types of measurements and mistakes that are done in measuring. We'll talk a little bit about the types of measurements that we can have. And then next Thursday, sampling, different sampling strategies that we can look at. And that one is very important. I just want to let you know that there's some review of different types of sampling that's done. And I should tell you that that's a very big topic, but only looked at very briefly here, but important in terms of testing. I will test you on chapter 4 for sure on the different sampling and calculations. And it is talked about also in the final exam. So important topic. All right, if there's no questions, I'm going to stop the recording. And